Hey guys, we worked through this problem about where to put the high school in between the two middle schools. We talked through these questions and then we worked through a handful of questions in class in section 5.1 in our workbooks. And this was on the topic perpendicular and angle bisectors. All right, and then we kind of switch gears. So if you look here at the assignment, it says, we worked on those table groups. We worked through Euclid's version of bisecting an angle, which was kind of new. And then at home, you were to check your understanding about parallel lines and triangle angle sums. So these are some things we've kind of been doing for the last few classes. And I asked you to work through these problems on page 87 and 88 in your workbook. Okay. So we highlighted these. This is probably the most important thing we're going to do. Is just make sure we get all the questions that we wanted to do. We highlighted the questions. These were the following questions we highlighted. 12, right? 15 on this page. And then on the next page, it was 18 through, 18, 19, 24 to 27. Okay, so let's take a look at those. 18, 19, 24 to 27. Okay, so let's take a look at these problems. The first question is error analysis. So we know off the bat that somehow a mistake has been made and the teacher marked it wrong. So we are to identify what did the student do wrong. So it says we have a triangle, right? And, very first day of class, we noticed we can't always see the triangle they're talking about. So we kind of have to think about how many triangles here. There's a triangle, there's a triangle, and there's a triangle. And a couple of different classes, we spoke about this, that a triangle, probably the triangle we're most used to, is an equilateral triangle. And notice all of the angles add up to 180 degrees. And you've likely seen this in a handful of classes from middle school. So we know that that's true. So as we look at this triangle, we can actually find this missing angle because we know those have to add up to 180. We also notice that this is a triangle. And we should be able to find this angle because we know both of these angles add up. So that could be another one we look at. So I'm just going to redraw this triangle here. If this angle was 56, and then this angle would have to be 44 and 31, so 75, then can we figure out this angle? Now using algebra from last year, we could do that. We could be like 56 plus the 75 plus this x has to add up to 180. Now, a lot of kids would just use a calculator and say, well, I'm just going to take 180 in my calculator and take away the 56 and then take away the 75. And there you have it, right? 49 degrees. So how could algebra have helped us with that? Well, we noticed here using algebra skills, we could combine these two. So I'd get 131. And then if I subtract 131 on both sides, I get 49. So it's the same answer. Those are two ways to doing the problem, but we definitely feel good about this 49. So how is it that they're calculating this and what mistake are they making? All right, so as we look at this, another student mentioned in class, well, we know that when we have a straight line, like in a protractor, the number on the protractor always goes up to 180. We can actually see this number to the left. You see like a 0 if the angle was not open at all, or if the angle is all the way open. We also see the number 180 all the way open. So we know that W and 56 also has to equal 180 because they make a straight line. This is called a linear pair. All right, and again, you may have seen that in middle school. So as we review this, what do we get? 124. So it says W is 124. W plus 56 is 180, linear pairs theorem. All this is good. We don't have a problem with that. So what do we have a problem with? Where they're talking about a new theorem or a new pattern that Euclid saw. He called it the exterior angle theorem, and he said that x, right, this part, plus the 31, this one, should add up to w, this one. And that doesn't make sense, right? We like 31 plus 49 does not add up to, what's that up to? So 80. That does not add up to 124. So what we were supposed to do, and I think what the student did wrong, was if we would have included both of those angles. Notice that 49 plus 75, if we extended this to 124, should add up to 124. So let's try that out. 75 plus 49. Yeah, 124. So what did they do wrong? This formula is wrong. W has to equal, yeah, that green, the x plus both the 31 and the 44. Or we could say W has to equal x plus 75. Right? So there you have it. All right, question number 15. Once again, we noticed that, and Euclid noticed that these three, that's a triangle. So these three have to add up to 180. X plus 3x plus 2x have to add up to 180. So using algebra, we have 1x, 3x, and 2 more x's. So 3, 4, 5, 6. So those are 6 x's there. And if we divide 6 on both sides, we get, this would cancel, right? We get x is equal to 30. So let's see if that makes sense in this triangle. Where x is, we can plug that in. That would be 30. Where x is here, 3 times 30, we get 90. Where x is here, we get 60. So we can double check our work. It's 30 plus 60 plus 90 add up to 180. Yep, it does. Okay, so we're feeling good about this. Now, what about the angle outside, this exterior angle? Well, we notice if this angle was 30 and we extended this line, then that would have to be 180 take away 30, or 150. Now, would this pattern that Euclid mentioned, it's called this exterior angle theorem, would this same pattern be true? So does the orange angle, is it equal to the green angle and the yellow angle? And the answer is yes, it absolutely is. 150 is equal to 90 plus 60. So it says, write and solve an equation using x. What is the measure of each labeled angle? So we found the measure of each labeled angle. 5x is equal to 150, right? X is equal to 30. The 3x is equal to 90. And the 2x is equal to 60. Here are all the angles. Nice work. All right. Now, those were really big problems. Those are big thinking problems. These are more direct questions. So it says, what are the values of the variables? Okay, so the variables would be x and y. So they don't necessarily need to know the measurement of the angles, although we could find them. They just want to know the variables. Okay, so that angle, right? We have 3 angles. So we just want to find the missing one, right? 180 take away 36. And then take away 46. All right, so I get 98. And we can double check that. Is 98 plus 46 plus 36 equal to 180? Yes, it is. Okay, so this angle is definitely 98. And we also know that vertical angles, you've also probably seen this in middle school, those two would be equal. So then can we use that to find y? And the answer is yes, all those three angles have to add up to 180. Y plus the 98 plus the 44 all have to add to 180. So again, you can do it by adding or subtracting. Either is fine. So we could do 180 take away 44. And then take away 98. Okay, I get 38. So my answer is x is 98, y is 38. Let's double check our answer is 38. If this is 38 and that's 98, is 38 plus 98 plus another 44 equal to 180? Yes, okay. Now looking at 19, we have this triangle, right? And we know two of the three angles, so we can solve for y. 180 take away 39. Take away 91. So I get y, that's 50. Y is equal to 50. And then here I have a triangle. I'm going to write it a little bit bigger because it's kind of hard. So they want x here, 71 here. And I don't know what this angle is. But remember, on the other side is 91. So in class, we know that these two angles have to add up to 180. So 180 take away 91 would be 89. Now I know two of the three angles. So I can do 180 take away 89, which is 91. Take away 71, which is 20. So y is 50, x is 20. Let's just double verify that is 89 plus the 71 plus another 20, 180. Yes, beautiful. All right, now they're asking using just this big blob of a bunch of triangles, can we find the answer to angle 1, angle 2, angle 3, and angle 4? Okay. We could go in any order. What we do notice here is we've got this triangle, and we know two of the three angles, so we can do that, right? Angle 1 would be 180, take away this first angle, and then take away this second angle. All right, so that would be 27. And we have this triangle, right? We know two of the three angles, so we can solve for angle number 3. We just do 180 take away 48. And then take away 74. Oh, that was 58. And then I see this triangle. They're not asking for it, but I know two of the angles, so I should be able to solve for this angle right there. 180, take away 122. Take away 16. So that's 42. And we know that this makes a straight line, right? This makes a straight line. So if this angle is 42, we know this angle is 180, take away 42. All right, and last one. I have three angles here. So it looks like I have, but I already know what this one is, right? Because it's 27 and 74. So that should tell me the angle left here, because that should add up to 180, just like on my protractor. So I have 27 and 74. So 101. This whole angle is 101. And I know 101 and that angle have to add up to 180. So I get 79. And that's it. Those are all the problems. Now, I want to talk again about this exterior angle theorem because these were patterns Euclid noticed. So let's see if we can double check our answer using the exterior angle. What they said is if you have a triangle and there's an angle outside, not inside, but outside, exterior, this angle outside should add up to these two on the inside, on the opposite sides. So 71 and 20 do add up to 91. Pretty cool, right? Here, we notice in this blue triangle, 101 and 48 do add up to 122. We notice in this triangle, see this as we extend out here, this 42 degrees and 37 do add up to angle 2. 42 and 37 do add up to 79, which is the angle outside. So you can also notice this angle here, 101 plus 37, does add together for this angle 4. 101 and 37 adds up to 138. Angle 4 we found was 138. So that's the exterior angle theorem. You don't really need it. You can just kind of work your way around the triangle, but it is a pattern we noticed, and it's a great way to check our answers. Nice work, guys.